Hey guys, welcome to a new video in this OpenCV Cuda module tutorial. In this video here, we're going to talk about image filtering on the GPU. So we're going to look at some of the different kind of like image filters that we have. So we can, for example, like have the Laplacian filter, like the Gaussian noise filter and stuff like that. And we're going to look at the different kind of filters and how we can apply them here in OpenCV with the Cuda module, so we can speed up the process of actually like smoothing out our image and also reducing the noise that we have in our images. But first of all, remember to join the Discord server. I'll link to it down in the description here. You can join the Discord server, chat with us about computer vision, deep learning, artificial intelligence, and so on. You can now also become a member of the channel if you want to support the channel more than you're currently doing by just watching with a small monthly fee, and everything will go to create more and better quality content here on the channel. So thank you guys. So first of all, as in the last two videos in this tutorial here, we're going through the documentation of the methods and like the module inside of like the sub module inside of OpenCV Cuda that we're going to use throughout this video. So know like what is going on. We need to specify like what the different kind of data types is actually like implemented, what filters and what like different kind of techniques can we actually use in the module that we're going to use. So first of all here, again, we're just going to the Cuda Accelerated Computer Vision module. Then we can see that we already went over the core part and also the operations on matrices. So how we can do like the core operations on matrices and also how we can do per element operations on matrices. So make sure to check that video out as before this one, because we're taking this step-by-step tutorial wise. So first of all, we're starting with the operations on matrices, then we're talking about filters. Then at the end of the tutorial here, we're going to focus more on like project related things with, for example, object detection, optical flow, like stereo vision and stuff like that, which is just a really nice and cool like applications and areas that we can use inside of OpenCV Cuda module, so we can speed up our applications and also just our OpenCV methods with the Cuda GPU. So in this video here, we're going to go into the image filtering here. When we're into this image filtering tab here, or like this sub module, we can see that we get like a class here. So we have this Cuda filter, and then we can see all the methods or all the functions that is implemented in this sub module here. So we can see we can create like a box filter. We can create some different kinds of, or like different like varieties of the box filter. So we can see we can create like a maximum filter, minimum filter. But in this video here, we're going to focus more on like the standard or like the most common filters that we're using in computer vision to actually like smoothen out and reduce noise in our images. In the computer vision tutorial that we already went through with the CPU, I talked a lot more in details about like what these different kind of filters does. When we actually like apply our filter or our kernel on our image, what it does and actually like how it reduces the noise. So if you want to know the theory behind it and you want to know more in details what these filters here actually like do, make sure to check that tutorial out where I go over like all the theory behind the basic stuff within computer vision. But in this video here, we're going to focus on creating like a Gaussian filter. I'm going to show you how we can create a Laplacian filter. It is kind of the same, but we need to specify some different kind of parameters. But we can just go into the documentation here, see what input parameters does it take and what is the output and stuff like that. So we can just create a Gaussian filter, Laplacian filter, and then one of the most used filters as well, or like different kind of varieties of filters, is the morphology filter here. So we're going to create that as well. So here, if you go into the documentation and hit this function here, we can see that we can create this morphology filter, and we can go and see the input parameter that it takes. We can also see the outputs, and we can see here with a small, like a short description, that this creates a 2D morphology filter. So we're actually like just applying a filter on top of our image, which is in 2D. The first parameter it takes is this OP parameter, which is an integer. And then we can see we get different types of morphological operations. And we can see that these following types are actually like possible and implemented in the Cuda GPU module. So we can use that for actually like speeding up our processes. So if you want to use, for example, erosion on our image, we can just pass in as the first parameter morph underscore erode. We can also use dilation, opening, closing, which is kind of like just doing erosion followed by dilation, and the other way around, where first of all we're dilating our image and eroding our image. So again, if you want to know more theory and details about all these different kind of things, because those are really important in the basics of computer vision, definitely check that tutorial out. I go over all of it, and it's actually like necessary to know to actually like be able to apply computer vision and know what types of filters that is best for your application or like your image. We can also see we can have some gradient here, top hat and black hat. And then the second input type here, or like the second input parameter, is the input image and also the output image, which is the type of it. And we can see here that only these data types here is actually like supported in this Cuda accelerated module. So we can see we can either use CV and then unsigned 8-bit integer with only one channel. We can also use 4 channels, or like we can also use floating points with 1 channel and 4 channels. So in this example, as I'm going to show you throughout the video, when we're going to create our program, we first of all need to convert our image from a BGR image to a grayscale image. So we're operating with 1 channel, and then we take like an 8-bit unsigned integer. So we're working with pixel values between 0 and 255, which is often the case. We can also use floating point numbers if we have a normalized image or something like that. We can also see the kernel. So this will be the 2D 8-bit structuring element for the morphological operation. So this is the filter size or a kernel size that we want to apply. Then we can also have like an anchor here, or like some number of iterations. So how many times do we actually want to do the erosion and dilation to apply it. Maybe sometimes we can get some improvement by doing it 2 times or 3 times, but again, it just takes up more processing power. But when we're using the GPU, it is still a lot faster compared to CPU. So you can probably just use like what's best for your image to reduce the noise. So here we have an anchor here, which is just the anchor position within the structural element. Negative values mean that the anchor is at the center, but in this video here, we're just going to set that equal to like the default value here, and we're going to do the same thing with the iterations. So you could change the iterations to 2 or 3, and I definitely recommend in your own projects and applications that you try to like tune this parameter here, or like at the least do trial and error. So we're gonna jump straight into the code here, and first of all, we're just going to include all the sub modules that we have inside of this Cuda module for OpenCV. We're not going to use all of them in this video. We only need this Cuda filters to actually be able to like create those filters that I just showed you in the documentation. Then we're going to use a namespace, the std and cv. So when we're going to use the functions from the Cuda module, we need to specify like Cuda colon and then the method, just so you know like when we're actually like using the methods that we're uploading to the GPU and doing operations on the GPU. So again, just we're opening up our webcam here, so we can actually load in the images from our webcam before we're applying our filters later on. Then we're going to print out the Cuda device info just to make sure that everything is set up correctly and we're using the correct GPU. Then we're going to create these data structures here, like we have a matrix here for our image that we're operating with on the CPU. And then we're going to create this GPU matrix where we can actually have our image on the GPU. So we need this data structure here when we upload our image to the GPU and do operations on that matrix. So here we're going to have a while loop. So we're just going to have this while loop running as long as our webcam is open, or until we hit Q on our keyboard down here at the bottom. Then we're also going to have this tick counter here as in all the other videos, where we're just going to start the timer, end the timer after we've done all of our operations on the images. Then we're calculating the total time, and then we get the number of frames per second with this like algorithm, or like this application that we're running, by taking like 1 divided by the total time. Then we're just going to put out the number of frames per second on our image, and at the end we're just going to show out our image as well. So inside of all this here, we're actually like going to create like write our own code here, and then create our filters, apply our filters on the images when we have uploaded it to the GPU. So first of all, as you know, we're just going to have this capture here where we're going to read in our image, and then we will store what we read in from the webcam in this im variable. Then when we have loaded it into this matrix, we can then upload it to our GPU, because we know that we need to upload it to our GPU, we do the operations on the GPU, and then we download it later on here again. So here we're going to write all of our code here. So I'm just going to make this comment. So here we're going to have image filtering. And then the first filter here that I want to show is the Gaussian filter. And we know when we're operating with the filters, it is only supported with 1 channel, or like with 4 channels if you're using that. But in this video here, we're just going to operate with a grayscale image. So first of all, we need to actually convert that to a grayscale image. So we use the method, as you know in the previous video, we can use the CVT color from the Cuda module. So here we're just going to specify Cuda colon CVT color. And then we need to specify what image do we actually want to convert the color for. And we're also going to specify where we want to store that image when we have actually converted the color. And then the last parameter is just the color that we want to actually like convert it to. So in this example, we're going to convert the color from BGR to a grayscale image. So we're only operating with 1 channel. So now we actually have our image converted. We can now create our own filters, apply different kind of filters, and we'll just see like how they work. Then you can go in your own application, tune the different kind of parameters, the filter size, and so on. So here we're just going to have this auto keyword here because the Gaussian filter, or like when we create the filter with the Cuda, we saw from the documentation that it actually like returns a pointer to that filter that we're applying. So in this video here, we're just going to use this auto keyword so we don't have to take care of the return type of our Gaussian filters or all the filters that we're actually like creating. So we're just going to use the auto keyword, and then we're going to create this Gaussian filter. And then we set that equal to Cuda : and then we need to have this create Gaussian filter. And then the first parameter is the source type of our a data type of our image that we pass in. So we know that we use this CV underscore, and then we use an 8-bit unsigned integer. So we have this 8U, and then we have a C, and then we have a 1 here because we're only operating with one channel because we converted our image from BGR to gray image. Then we need to specify the output as well of the data structure, or like the data type. So again, we just specify here CV underscore 8U, and then the channels, and then we have a 1 here at the end. So now we need to specify the filter size, and the default one, or like the most common one, is just to use like a 3x3. We can also use like 5x5 and so on. But the more you increase in size, like the heavier the computation will be. The end parameter here is that we can see that we have this double here, which is just a sigma. So how much do we actually like want to apply this filter, or like this is just a constant for our Gaussian filter. So we're just going to set that equal to 1, which is just like kind of default. But these are the two parameters that you can like play around with for your own application, or like for your own image, to reduce the noise and smooth out the image as much as possible. So now when we have actually created this Gaussian filter here, we can just hold it over here. So we can see that we have this pointer that contains this Cuda filter in like this Cuda filter here. So instead of typing like all of this, like the whole data structure here, we can just have this auto keyword here instead, which is like just more intuitive and more easy to use, and we will just reduce the errors in our program. Then we can just use, to actually like apply the filter here, we just call this Gaussian filter. So this will be the exact filter that we created up here. So we're just going to copy paste that. And then we need to use the arrow operator because we actually like have a pointer, and when we want to use like this class here and access the method inside of this class, which is like a pointer, then we actually need to use this arrow operator instead of the dot operator. This is just like how C++ works. So here we're just going to use this function apply, and then inside of apply we need to specify our input image and output image that we want to apply the filter on. So here again we're just going to specify im GPU, and our output image will also just be our im GPU. So now we actually like have everything here. We are creating the filter and we're applying the filter. So this is actually like how we can create the filters here in OpenCV with the Cuda module. So if you just go down here to the bottom, we can then build our program and run it and see how it actually works when we're reducing noise when we're applying this filter. We can see that the build finished with exit code 0, and we're just going to hit this run button here. So now we're running the program. It will just start it up. We can see that we get all this information out here from our GPU. And here we can see the output. So we can see that first of all, we're grayscaling the image, and we can also see like some of the corners, or like some of the edges here is actually like smoothened out because we're using this Gaussian filter here on our image. So this is actually like the result when we're applying this Gaussian filter. We can play around with the parameters if it is not reducing noise enough in your image or in your video sequence. So here we just hit Q again to terminate the program. So the next filter here that I want to show you guys is just like another filter, so we can see the result of that, and so you can get like more practice with how we can create these filters and apply them. But we can kind of follow the same method here. So the next filter here is just the Laplacian filter, and again, if you want to know how you can actually like what the theory behind these filters are, make sure to check my tutorials out on that as well. So here we're going to create this Laplacian filter, and we set that equal to Cuda : create, and then we can actually see here all the different kind of things we can create. So I'll just go down to create Laplacian filter. So we could also see that we can create some like half transform like detectors and stuff like that for circles and lines, which we're going to cover in another video throughout this tutorial here as well. So here again, we're just going to copy paste all of this up here again, because we're going to use the exact same data type. But in this here, we actually like don't need to specify this filter size, we need to specify like a 3 and a 3 here. So this will be the scale. It will be the K size here, and also the scale of how much we want to apply this Laplacian filter. So this is just like the theory behind it. You can tune these parameters for your own image and application. So again, we're just going to create this Laplacian filter, and then we're going to use the arrow operator to actually like apply the filter to our image. We have this im GPU, and our output image will be the same again. So you can see that this is exactly the same as we just did. This is just to show you another filter before we're doing the morphological filter, which is where we have to do a bit more stuff, and also we have more varieties inside of that filter. So again, we're going to build our program, and then we can run it after it is done building. Now we can see we print out the information again. We open up the image, and then we can see now we're actually like applying this Laplacian filter. So we can see that we get like this kind of like edge detection in our image. We can also see the number of frames per second. So this is like a fairly high amount of frames per second, because we actually like need to upload. We are also timing the upload of our GPU, or like our image to the GPU, and also the download. So it will like speed up the process more if you're doing more operations inside of this timing loop that we have. But we see that this is actually like really nice Laplacian filter. It gets a lot of details up here, like in the edges, in the hair, and also in the background and stuff like that. So it can be used for a lot of different kind of things, and we use the Laplacian operator or like the Laplacian filter a lot. So this is just to show you how we can apply another filter and what the results for that filter is. The last thing here that I want to show is the morphological filter. So we can do some different kind of things as I showed you in the documentation. So again, we're just going to have this auto, and then we can just have morph filter, and we set that equal to Cuda create morphological filter. We do the same here, but now we need to specify the first parameter here, which was the operation that we want to do. So in this example, we're just going to do closing. So we can just have this morph, and then we can see all the things here that is actually like implemented. So here we can have morph open, or we can also have morph close. So we just need to specify what type of operations that we want to do. Then we need to specify this data structure, or like data type. So again, we have 8 U, and then U, and then the channels, and then we have a 1. And then at the end here, we need to specify the kernel here, or like this, the kernel that we want to apply. So this will just be 6. Just to show you an example, it could also be 3, it could be 9, it could be 12, it could be like an arbitrary number. This is just like the filter size, or like a kernel size that we want to apply to our image when we're actually like sliding it over our image and applying this operation. So now we have created this one here, and we can go down and actually like use it here again with the apply operator. Apply, and then our input image, which will be the im GPU, and our output image will be the same. And just as the last example here that I'm going to show, this morphological filter, we can hit build, and then we can run our program afterwards, and then we can see the results. So now we're just going to run the program. It will open up this same thing again, but now we can see here that we are applying closing here on our image. We still have a grayscale image, but now we're applying closing to reduce some of the noise. And again, if you want to know the details about what closing, opening, erosion, dilation, and so on is, definitely check those tutorials out, because or else you wouldn't really know like what type of operations do we actually need to apply, and if we want to use like dilation before erosion or the other way around. But here again, just to show you, like we can apply something else. We can just go in here, instead of close, we hit open, or we can also have like erode, as we know. So in this example, we're just going to take erode. We're going to build a program, run the program, and then we're just going to end off this video here. So now we're going to run the program for the last time. We're opening up everything again. We get all the information, and now we apply this filter here. Again, we can see we don't really get like that many differences here, because we only have a grayscale image. Morphological operations really work really well on, like, for example, binary images where we want to reduce the noise. If we, for example, have some dead pixels, or like dead pixels inside of objects that we want to segmentate out, then it's really good to like use, for example, like closing to close out these different kind of like false pixels that we have inside of the objects. So we're going to apply morphological operations when we're going to do background segmentation here as well in the Cuda module. So that's pretty much it for this video here, guys. We've been over like all the different kind of filters, how we can create a filter and apply a filter, and we're going to use it later in other videos where we want to reduce the noise in an image before we're doing our operations. So thank you guys for watching this video here, and remember to hit the subscribe button and bell notification on the video. And also like this video here if you like the content and you want more in the future, because it just really helps me and the YouTube channel out in a massive way, and I really appreciate it. Again, I'll link to the tutorial with the computer vision up here if you want to know like all the theory and details behind all of these different kind of like algorithms, and also just the theory behind computer vision in general. So I'll link to the tutorial up here, or else I'll just see you in the next video, guys. Bye for now.